Next, we look into angular momentum. Angular momentum is a three-dimensional situation. As you see on the screen here, if a particle move in a plane like a piece of paper on the surface of a paper, so if this blue color line, we call it path. So when this particle move with the velocity, you have momentum, right? So this angular momentum give you h. Is like a concept of moment that you learn in your statics. What is moment when you learn in statics? What is moment? You still remember? Okay. So when you have a reference point, let's say O, and you have a force, and you have a distance from the reference point. This is a reference point. So when your force move perpendicular to a distance, it will create a moment. Will give you F cross D. All right. So the moment, the definition of moment is you take force multiplied by the distance perpendicular to the force from the reference point. You create moment. You apply the same understanding for angular or momentum. In this case, the word momentum and angular. So we are actually looking at the momentum. Multiply by the perpendicular distance, we get moment actually. The you can say it's a moment of momentum. Okay, you take momentum, mv multiplied by the distance perpendicular to the direction. Okay, f is a vector, so same. mv also is a vector, right? So you use your right hand rules, direction of angular momentum, you use your right hand rules. Like for example, if this case is in this direction, so the direction is going up lah, if it's following your finger. Okay. All right. So we label angular momentum by capital H. All right. It's a moment of momentum. So moment is the one that I write on the whiteboard here. What is the definition of moment? Vector cross the perpendicular distance. You get moment. So moment of momentum, actually you take the concept of moment, but you use not force, but you use momentum. Momentum is mv, right? So I simplify everything. So the magnitudes of h or angular momentum is d multiplied by mv. D must be perpendicular as what we define for moment, right? mv we already learned, right? Direction, the magnitude is d multiplied by momentum. Direction is following your right hand rules. Either come up from the paper or following the thumbs. So you're always perpendicular to axis. Okay. This is the plane that the momentum moving, the A4 paper plane. And the direction is perpendicular and following your thumb. Unit is kilogram meter square second. B is meter. M is kilogram. Velocity is meter over second. So meter, you have meter square. M is kilogram. Stroke S is because of the velocity. So the unit is kilogram meter square over second. Okay. So this is the first introduction of moment of momentum, or angular momentum. So if you want to write our formula in a vector form, it's still the same. What you see on the screen here, the r is the distance and mv is the momentum. So when we want to write in the vector form, is depend on the right hand rules. So it depends on the direction of your MV. MV is your finger direction. So if you see, refer to this diagram, refer to the reference point here. So if we follow the path, our finger will curve in, and direction your thumb will point out from the screen. So this is how we process it when we look in the vector dimension. H equal to R cross MV. R cross MV. R cross. Cross. It must be in this direction. R cross. R cross MV. And if you flip the direction, then you get a negative. Means it's go inside the screen. Okay. Okay. So when you analyze vector cross, you can use matrix form. This is what you learned in your Max 3 or Max 2, I forget already. But this one is a matrix form. So you know that your R has ijk. MV, the velocity have ijk also. So you put your R first row, MV second row. Then when you do analysis, you cross the things, right? You do this one multiply this one multiply this one multiply this one, and so on. Okay, so if you forget how to do matrix already, flip back to your mathematics textbook lah. We assume you already know how to process this information. Okay, all right. So we can use angular of motion or F equal to ma to solve our problems here. Okay, so if there's a particle moving along the pathway, but there's an external force acting on the bodies in this case. So when there's a force, we can convert the force into mass and into the acceleration motion, ma, right? In this case, so F equal to ma, a equal to dv dt, right? Okay. So if we take moment equal to rf, right? Moment equal to r cross f. Moment equal to r cross f. R cross f. Then we substitute the definition of F equal to ma inside there. Why we die also want to calculate the V? Because angular momentum and V, we want to relate acceleration, the force into velocity. So we force to use, I mean, we try to rewrite our equation, F equal to ma, convert A into dv dt form, and we want to see the velocity because we deal with momentum. Okay, so from there is appendix B. Appendix B in the canvas. If you haven't read, go ahead and read it. So there is a derivation on the cross product, how you do cross products, right? So just now we know the angular momentum or moment of momentum equal to h. If we differentiate with time, we have a dot there. So when we move, when you write h dot means we differentiate r cross mv with time. Okay. So this is two cross products and we differentiate. So go and see appendix B, how this process can from here to here. There's a explanation, detailed explanation there. Go and see the appendix B. So from this to this, so R cross MV plus R cross MTV is a chain reaction, is a chain rules, right? Okay, so here is a side note lah. It's a side note. So R dot cross MV, you can write equal to R bracket R time differential of the R cross R. Okay, R cross R is 0. R cross R is 0. It's like using your right hand rules. When you cross the same thing on the same line, you don't go anywhere. right? You can't even cross your hand, right? It becomes 0, right? You R cross R means you cross yourself, cannot, right? You move in a straight line, so there's only one direction, so there's no another direction coming out, so 0, right? So you cancel out the orange color, then you arrive at this one. Okay, so here it arrive at R cross MV equal to H dot. H dot means the time differential of your momentum, right? Of your angular momentum. So this M equal to H dot. H dot. Okay. So when do we apply this equation? Is that on the left is moment. So this one you learn in your statics how to get moment. This is from the reference point. Moment from the reference point. This one you referring to force. The left hand side refer to force. Force multiplied by the R or D, you get moment. Right hand side is a time differential with the dot on top of the H. Is a time rate change of your angular momentum about 0.0. So here you find the moment of momentum, then you time differentiate, you dt, you do differentiation towards time. Okay, so left hand side, right hand side. Left hand side, if the question asks you to find force, you use this one, or it asks you to find distance, then this one. This normally you can get from the question. The question will give you force and the distance. You can get the left hand side. Right hand side normally is the missing information here. Okay. So if you have a system of particles, you just add another sum lah there. Okay. So what is important for the second half is this equation, right? So it gives you moment. You can use moment equal to the dh dt, means you take the angular momentum, differentiate with time. Okay. So let's see how this one works. So when you know that you need to use this formula, angular momentum, you look at the question when you see R with theta, very high chances you need to use right hand rules or angular momentum equation. So you have a sliding from one position, high ground, to a conveyor here. So parcel with the velocity v and the distance of r. So this is a curvature motion with the r. So curvature motion, you have normal and tangent direction. So you can solve using normal and tangent direction until this point here and this here. So you're given mass m, travel smooth circular ramp. So smooth means no friction, such that when it's at the angular theta, so this one is theta, typo error, it has a speed of v. Determine angular momentum about 0.0. At this instant, you need to find angular momentum at these terms, and the rate of increase in the speed. Rate of increase in speed basically is acceleration. It's acceleration. So sometimes the question will confuse you a bit with the terms. For example, rate of increase in the speed is an acceleration actually. Okay, so you draw free body diagram. Our focus here is not conveyor, is not the ramp, but it's the box. So you draw the box with free body diagram. In this case, it's come from a circular motion, so you draw normal and tangent. In this case, you should already understand why normal pointing here, tangent pointing here. All right. Then from there, you put in all the information from the center O, R, and so on. So as you know, when you have normal tangent, you have acceleration. Acceleration in tangent, there's one equation there. Acceleration in normal, v squared over rho. This one. So in this case, R is a parameter. So you put in free body diagram, Free body diagram, you put in all the forces on the bodies. In this case, you have weight, and there's no external force pushing the body, so no external forces there. You only have a body weight. Okay, but again, highlight the red color arrow because as you learn further and further, you will forget normal. So I already marked your test one. One of you, I don't know, somehow you give the wrong direction of n. I don't know, somehow you draw your n like that. I don't know. Somehow you draw something like that. Okay. You are focusing on the bodies. The normal always pointing to the bodies and not to the floor. Yeah. If you're the one who draw this one, don't make the same mistake for test 2 or final exam. Means if you draw this one, I don't need to mark your question already. Straight 0. I don't need to mark because everything wrong already. Right? So you put in the angular moment equation. Angular moment equal to mv multiplied by the d, moment of momentum. Moment of momentum, you put the momentum multiplied by the distance, perpendicular. So where does the object move? So we assume that our z is coming out from the screen. Oh, sorry, not coming out, going in, because we want to follow the V here. The V is actually our fingernail. So fingernail go down. You want to cross, you only want to cross, right? So our direction is going in, and the finger curve is actually the direction. So here, right, the direction is actually curved in. So it's a clockwise direction. Right. So your direction is H equal to R mv. In this case, you change your D to mv, and it must be 90 degree. Yeah? It must be 90 degree to the momentum. So in this case, R always 90 degree to your momentum because it's a curve. Your tangent direction always tangent to the curve, right? Right. So the rate of increase or acceleration dv dt a equal to dv dt can be found by this equation. You can change the information of moment equal to the rate of change of your angular momentum. Right? So how you find your moment? F multiplied by d. So there's only one force here. Why normal do not create moment? Why? Why normal do not create? Why your normal do not create moment? Why? Why your n do not create moment? What is your d? F moment equal to force cross d, right? Your n. What is your d? D0. Okay. This is reference point. O. This is R. N always go along the R. This is perpendicular distance. So when perpendicular is when it's go parallel, there's no D there. There's no D, D0. Because N always pointing to the center. In this case, it's always pointing to the center of the curve. So no D. Okay, no D. Okay. But if there's an external force here, then force multiplied by R, there is a force. There's a momentum. there's a moment. Yeah, when only you have perpendicular with the distance and force, then only you create moment. If it's do not have this case, then no moment. Okay, so in this case, normal always go parallel to the radius, so no moment. Yeah, so this explains why n in the collinear motion, n doesn't create moment. So in this case, we only look at W. W, we split into X and Y, or in this case, in tangent and normal direction. This is collinear motion. So collinear motion, we look at T and N. So split your W into T and N. T and N. So one of you in test one also make careless mistake in your positive negative direction. Your W suddenly get positive. So in this case, your W negative go here, right? Right, so in this case, mg, in this case, how to get moment? Moment must be perpendicular to the distance. So this one split to t. Okay, there's an angle here, right? So it's a sine, and also that's one. One of you are very weak in trigonometry. You use the wrong sine and cos relationship, so the whole solution is wrong. Okay, so this one, so if you're weak in trigonometry, especially sine cos, then go and practice. All right. Don't start in engineering dynamics because of trigonometry or integration. Okay. All right. So when you put in the moment, F multiplied by D, F multiplied by D, your F in this case is width, D is perpendicular distance, or you can put in sine over here. It's the same, right? Then H dot means H is moment of momentum. So moment of momentum R mv with the dot means dt. Okay. So R constant, M constant. So R constant, M constant, pull them out. R constant, M constant, pull out. So you only arrive at dv dt. The question asks you rate of increase on speed. If it is this one, you have this one, mg. You have the R, you remain. So you can move, actually, you can move your R to right hand side, you can cancel. Cancel your M. Then you can get G sine theta is your A. That is your answer. Okay. So basically, the code question asks, want to test you that do you understand the definition of momentum, angular momentum, and then change moment to rate of change of your angular momentum. This equation and this equation. Then you expand the definition, then you'll get the answer. Okay. So I give you another solution. If you use F equal to ma to solve, like what you learned in chapter 2, F equal to ma, you can solve using chapter 2 equation. But sometimes the question will force you to use equation of angular momentum. If you see the question mention angular momentum, then you need to use the previous one. If the question do not see this one, you can use F equal to ma chapter 2 question. Right? Same, same. Chapter 2 straight away give you the answer. F equal to ma by using collinear motion. Okay. Yeah. Still confused with the direction. Okay. So if you use your right hand rules, your fingernails actually your velocity. your velocity. You follow the velocity direction. Then the R. The R is here, so the R is here. Your fingernails pointing this way. Your fingernails is pointing this way, this direction. So your fingernail pointing here. So your thumbs will automatic point inside. So it will make you clockwise. Okay. All right. Then they also have a principle or something. Same. But you're looking at the name, you already know what equation that you should use already. Principle of angular impulse and momentum means it involves angular impulse and momentum. Okay. Angular impulse is your right hand rules. Momentum is FD. F multiplied by D. Right? So you rewrite your equation. Momentum equal to the rate of change of your angular momentum, H dot. You rewrite in this form, M equal to dot, you change the dot into dt. Then we don't like this form. We pull the dt to the left-hand side. So you get M dt equal to H. Then we also don't like dt. We will expand dt with the integration. When you integrate left, you integrate right also. You integrate with time. Here also, integrate with the change of your H. H is your angular momentum. So here, if you use principle of angular impulse and momentum, so same like the principle of linear impulse and momentum. Here is angular. So angular is right hand rules, right? So you just rewrite this one. Either form, this line or this line also correct. So if you see the question force you to use principle of angular impulse and momentum, write the angular impulse equal to the change of momentum. Okay, so you write H plus M dt integrate equal to H number 2. Okay, right. So this one will be in your test 2 lah. It will be in your test 2. So here, just need to highlight this one M dt. M dt, the moment is R cross F. You always take R cross F. Of course, in your statics, maybe you're not focusing on the cross products, right? So R cross F. Just now is R cross MV, but moment in this case is R cross F. Okay, R cross F. Okay. So this is just another derivation. So for your test, straight away memorize the sum of H1 plus the momentum multiplied by time. Momentum multiplied by time is the impulse, angular impulse, right? Angular impulse is momentum time. Linear impulse is force time. Yeah, linear impulse is Ft. Angular impulse is Mt. Momentum, moment time. Okay, moment time. So angular is linked to moment, linear linked to force. So don't confuse between these two. Okay. So the rest is just a derivation of how you solve normally. So vector form is in this form. So velocity vector, force is vector, and so on. So if you want to go this way, you need to use the matrix method. You want to go simpler way, you split into x, y, z direction. Means one body, again, this one look, when you want to use principle, you look at individual bodies. So here, individual bodies have mv1 plus Ft plus mv. This one is, I think is something wrong with my equation. This one is linear impulse. Sorry, this one is linear impulse. But angular one, same, you do the same. Change the force into moment. Change the force into moment. This side become h, this one become h. Okay. So it's the same lah. So this one, the first three, mv, x, y, z, this one is linear impulse because of f. But there's one more equation to help you to solve if anything missing here. If let's say you have four unknown, you only have three equation not enough. You want to add one more with using angular equation, angular moment equation to solve the fourth unknown here. Okay. This is the full set lah. This is the full set equation. If you really don't know how to solve, you write this 4 and then you substitute the value inside here. You will see that something will be missing, either these three, these 4. This equation help you to solve moment. Moment is force multiplied by distance. So something will be missing here. One of the F will be missing. So you find this one, substitute inside there, or find this one, solve simultaneous equation. Then you're able to find the force from here. Yeah. So also when you have principle, you also have conservation. Same, same principle. So when you can use this one, when you have an internal, you ignore the internal time, right? So okay. So let's look at one example, then we conclude chapter 4. So let's say you have a car moving in the path like that. When you see this photo, you already know this is a collinear motion. Collinear motion, straight away draw normal and tangent direction. Okay, draw normal tangent direction. Then proceed with the collinear motion procedure. A equal to AT plus AN. Right, AT equal to dV dt. AN equal to V square over rho. There's an equation for the rho. Straight away, right? What rho equal to differentiate one time, differentiate two times, and so on. Okay. So in this case, you are given the mass of the car, circular road, traction force is given, traction on the road is given. So your force changing. So your normal, your Newton equation cannot be used because acceleration changed already. So this should be known. So determine the speed of a car when time equal to so and so. When you see time is linked with impulse already. It linked with impulse already. So travel at speed so and so, ignore the size of the car. So you need to find the speed when it reaches certain time. All right. So you draw the car in this way. So you draw the object in 3-dimensional. Your weight is going down. Your car is moving forward. R is 100 meters. All right. And don't forget normal force. Normal force pointing towards the body, not towards the ground. When you draw N towards ground means you're focusing on the ground, not on the car. Okay. All right. Okay. So from there, there's a force. There's a traction force. And there's a R force on the vehicle. So when we want to use principle of angular impulse and momentum, okay, Okay, so the impulse will be eliminated by the weight, normal force, and radial fraction, right? Okay. So you pull out the principle of angular impulse and momentum. Angular impulse is moment multiplied by time. Linear impulse is force multiplied by time. So principle of angular impulse is moment multiplied by time. You integrate momentum and momentum. It actually is the long one is actually is principle of angular impulse and angular momentum. If you want the long version, it's actually both are angular impulse and angular momentum. So angular momentum is h. Yeah. So the long version, we just simplify it, become angular impulse and momentum. So actually it's angular impulse and angular momentum. Principle of angular impulse and angular momentum. We just don't want to write a very long sentence, so we write angular impulse and momentum. Both are angular. So in this case, you write, you change the general equation into z direction. Z direction. You are using right hand rules, right? So in z direction. So you put in all the parameters. Angular momentum is r cross mv, r cross mv. And the angular impulse is on the individual bodies, so we can use impulse. So impulse is rf, is mdv. Angular impulse is moment time. How you find moment? R cross f, r cross f. Your r and your force is because it's angular, so your force is always perpendicular to the radius. Tangent direction is always perpendicular to the radius. So force r cross f create moment, and h is angular momentum. Angular momentum is r mv. You put in the information. R is 100, m is 1.5 megagram, change to kilogram, it become 1,500 kilogram. V is 5. Okay, it tell you the velocity, 5 meter per second. Okay, same, you repeat the same for the second one. RMV 2. So R same, 100, M same, velocity we don't know. So when we don't know, we just put back the unknown. Okay, then the impulse also same. Angular impulse is moment time. So R is 100, force is changing. Force is 150 t squared. Integrate dt, so this is integration problems. I highly recommend you pull the constant out first before you integrate. Pull this one out. Then you solve the dt. This one become t cubed divided by 3. Then only you substitute the time there. Okay. So from here, you substitute all these things. The answer for this one is you'll find. The answer for this question is 9 point something. Okay. So this one. This one is the force that keep the car from the direction. But this one again doesn't create anything. This one, if you look at the either moment or momentum, this one doesn't create anything like the one that I draw on the spot here. It always go same direction with the R. So the D 0. So it doesn't create any impulse or any moment. Okay. So there's a force, try to force the things inside. Okay. The force is from here because the diagram here give you the force. Yeah. But anyway, if this one come out from the in the test, if you forget to draw this one, still okay. Still okay. Okay, so I think this one, example 11, home and read the PowerPoint slides. I need to highlight is that in this case is elastic. So when it is elastic, you need to be careful. There is an elastic force in this direction. So there's an elastic. I want to show you the direction. So you read the PowerPoint slides. Only need to be careful on the force there lah. Okay, this one you read lah. It's your homework. So go ahead. Again, your focus when you solve this kind of question, focus on the object itself and not be confused by the system. Right? For example, if you look at the screen here, if you are the round object, you should always remind yourself what do you feel if you're in a motion. So in this case, if you're tied to something, there's something pull your shirt. The force direction is out of the bodies and not inside. Unless there's a spring. Spring, you move toward the spring, you're pointing in. You move away from the spring will pull you. So, but again, the main concept is you imagine yourself, what do you feel if you are that object? Okay, especially when deal with the force. And contact force, don't forget. Don't forget, because as we move on, you might forget the contact force. Because the question will no longer mention contact force for you. So just take note lah on the normal force, contact force. Okay, this one you read your homework. And if you're not able to solve the question, always remember you can use energy to solve. Energy, when you see spring object, elastic object, there will be energy problems. Energy problems, you have spring, you have potential energy, you have datum, then conservation energy will help you to solve this one. Okay, but in most of the case, you don't need to use energy unless you're seeing elastic or something or velocity, or there are some unknown that you cannot find, then you use conservation of energy. This one is outside the scope. If you're taking aeronautics engineering, then we'll go into steady flow or fluid mechanics. If you take fluid mechanics, you can also use principle of impulse of momentum if you are taking fluid mechanics or fluid FEA. So you're taking fluid dynamics this semester? No. Yeah, right? Okay, some of you are taking. So actually, you also learn principle of impulse of momentum also. I'm not sure whether it's inside your modules, but if you're taking, you're doing the same, right? You are still seeing the same thing, but it's not. I will not ask you for engine dynamics. It does the same, but it will be using the cross products. You will be seeing at the end all this change of mass equal to rho dv and so on. But I won't ask you. I won't ask you. This one also this one extra information for you. Okay, so with this, we conclude chapter 4. I will see you next week. We go into chapter 5 already. Okay, sign your attendance. Remember to sign your attendance.